One sequence of numbers you're expected to be able to recognise are triangular numbers. So this is very easy once we start to draw it. Start with 1. Sorry, let's make that a little bit bigger. Okay, so I've got 1 dot. So for the next one, I've got a group of 3 dots to represent the 3 numbers. Now, hopefully you're seeing the pattern. So I've made another triangle here that using 6 dots. Here's the next size up of triangle that has 10 dots in it. So hopefully you're seeing the pattern here. So for each extra layer we put onto our triangle, we're putting on 1 extra dot in the line. So the bottom of the 6 triangle had 3 dots, the bottom of the 4 triangle had 4 dots. So to make the one that makes 15, we're going to have to add extra line that's going to have 5 dots in it, and as you can see, the dots in the rows below always go sort of in between the ones above. So that's triangular numbers. So this is the Fibonacci sequence. Let's have a look at how this works. So the first number in the sequence is a 1, followed by another 1, and if we add those 2 ones together, we get the next one in the sequence. Then if we add 1 and 2 together, they make 3, which gives us the next one in the sequence. And I think you can see what's going on here. So 2 and 3 added together gives us 5. 3 and 5 added together gives us 8, and so on. 13 and 21, if we add those together, will give us the next number in this sequence, which is going to be 34. So here's an example of a Fibonacci-like sequence, which just means that it's going to use the same rule about how you add the 2 numbers together to get the next one in the sequence. So let's say our sequence starts with a 1, but then it has a 4 next. So we add the 1 and the 4 together, that gives us 5. Then we add the 4 and the 5 together, that gives us 9. 5 and 9 together gives us 14, and so on. So that would be a Fibonacci-like sequence as opposed to the actual Fibonacci sequence itself. So you're also expected to be able to recognise arithmetic sequences. Work out the difference between the 2 terms here. 4 from 7 gives us 3. 7 from 10 gives us 3. 10 from 13 also gives us 3, and so on. So if we take away consecutive terms like this and we get the same number every time, then that is an arithmetic sequence. I'm not going to go into how we do the nth term rule here, that's a whole nother video. So here's another example of an arithmetic sequence. So in this case we've got 17, take away 12, so that's minus 5 we've got there, because it really should be 12 take away 17, of course. 7 take away 12, that's also minus 5. 2 take away 7 also gives us an answer of minus 5. So that's what we're looking for to spot an arithmetic sequence. Now we're going to look at geometric sequences. Now you're not expected to understand these at the same level as arithmetic sequences, and again in this video I'm just talking about how to recognize them and spot them. So instead of working out how much the difference is by taking away the terms here, if it's a geometric sequence, what you'll notice is that there is a multiplication or a times effect going on between these. So 15 divided by 5 gives us 3. or the other way round if you prefer to see it like that. So 5 times 3 gives us 15. We then do 15 times 3, we get 45, and so on. So that's times by 3. If we look at the other example there, we can see that in this example 12 goes to 6. That involves dividing by 2 or multiplying by a half. The same thing, just to get it into your head, okay? So then we're dividing by 2 here again, but in terms of the sequence, actually we should properly think of it as halving, so timesing by a half, and then a half of 3 is 1.5, and so on. So if you're doing an example, a question where they ask you to recognize different sequences, basically the way that you're going to recognize that something is a quadratic sequence is by recognizing that it's not any of the other types that you know. So it's not triangular, it's not an arithmetic, it's not a geometric, it's not Fibonacci, it's not square numbers, it's not any of those other sequences you know, then it's going to be the quadratic.